Question 8. A survey carried out to estimate weekly rental cost of holiday apartments in a certain country. A sample of 400. So I have my N. The mean of the sample was 400 euros, just to confuse you. Standard deviation of 50. Form a 95% confidence interval. Well, 1.96 multiplied by standard deviation divided by the square root of N, which is the square root of 400, which is 20, which is 1.96 by 5 over 2, 1.96 by 2.5. It's going to give 4.9. So I add 400 plus 4.9 and 400 minus 4.9. It's money. So my confidence interval here, mu, is between 400 and 490 and 395.10. So nice easy question 8. Question 9. Farmers measured dairy milk production in pounds. Ayrshire, so we have two different types. We have Ayrshire 47 a day, standard deviation 6, and then we have Jersey 43 pounds per day, standard deviation of 5, and it's normally distributed. So question A, probability randomly selected Ayrshire produces more than 45. Okay, let's do a little sketch for Ayrshire. We're looking at more than 45. The average is 47. So we're looking at more than 45, which is the same probability as less than 49. So just to keep it positive, I'm just going to get the test statistic 49 and see what that gives me. 49 minus 47 over 5. Sorry, 6. We're copying the wrong one, just be careful. Over 6. That's 2 over 3, which is a third. So a z-score of 0.33. I'll just round it off to 0.33. We could take it a little bit in between, but they're not going to make a huge difference. 0.33, 0.6293. So the probability of less than 49 is equal to 0.6293. And the probability of greater than 45 is equal to 0.6293. Part B, 20 Jersey cows are selected at random. The probability that 2 or more of these, so this is Bernoulli, isn't it, will produce 54 pounds of milk a day. Right, well, we need to get the probability of success and hence the probability of failure and apply a Bernoulli trial to this. Okay, so they're bringing in a couple of different things here. So what have we got for Jersey cows? Let's write down what we have. We have average of 43. Going to use the same table here. Average of 43. Standard deviation is 5 this time. The correct standard deviation, 5. And we're testing more than 54. Okay, so we're up here, greater than 54. So 54 tested against an average of 43 with a standard deviation of 5 is 11 over 5, or 2.2. So my z-score of 2.2 gives me 0.9861. So that's the probability of failure. That will be less than 54. Probability of success is what's in the tail, which is 0. We have to add 0.139, the probability of success. So 20 is the sample, and the probability is that 2 or more. So the probability that 2 or the probability of 3 all the way up to the probability of 20. So we need to get the probability of 0, the probability of 1, and take that away from 1, and we'll get the probability of all the others together, or 1 minus the probability of 0 plus the probability of 1. Might be a nice clean way of looking at it. So the probability of 0 is 20, choose 0, by the probability of success to the power of 0, so just probability of failure, 0.9861 to the power of 20. And the probability of 1 is 20, choose 1, by success, 0.0139. One success, which would leave 19 failures, 9861 to the power of 19. And typing these two into our calculator, 20, choose 0. First one is 0.765. The second one is 0.213. If we add them together, we're going to get 978. 0.978, so 1 minus 0.978 is 0.022, is that right? Sorry, 678. I'm just checking back, I thought it was a bit low. This is actually, I must have typed it in wrong, 7558. 7558. Which gives 0.9688. And if I take that away from 1, I get 0.0312, 0.0312 here for this part B. And part C, 400 Friesian cows are randomly selected. The mean production of this sample was 47. So mean is 47 of this sample. And standard deviation 6.5. Find a 95% confidence interval for the mean production per day of this breed. So 400, they've written it in words, n is equal to 400. So we've got our sample mean. We need to multiply 1.96 by standard deviation divided by the square root of 400, and that will give me 0.637. So I'm going to get 47.637 at the higher end for this population, and at the lower end I'm going to get 46.363. So my 95% confidence interval for Jersey cows, Friesian cows.